queuing QD testing. Let me quickly show you, and then one question will come straight from queuing. So I don't know about the rest, but at least you all of you can make you benefit of that. Okay?
Essay.
Numerical problem. One full numerical problem.
Yes, but in the essay what?
In the essay part, yeah. Numerical basically meaning that other than MCQ, you will have one full essay part. Okay? So do you remember I talked about this MM1Q? I hope that you remember something, and there was formulation discussed. Lambda was the arrival rate, which was customers per second, per minute, per hour, per unit time. Right? Do you remember that? I'm going to do a quick review. After that, I'm going to give you 2 sample problems. I'm going to solve it here. I'm going to share it on Blackboard, and then I'm going to give you some extra practice problem. You do that class, you should be able to secure full score on the numerical part itself. Not very difficult, straightforward, right? But I'm going to tell you where students go wrong. So please pay attention. Okay, so please pay attention. 1, 2, 3, 4, 5, 6, 7, at least 7 of you should pay attention. I cannot guarantee about the others. Okay, so lambda is the arrival rate, mu is the service rate, number of customers served per minute per second. One of the things I mentioned to you that there are always 2 things that come together. One, the rate and the time. Rate is customers per second, and the time is time between customers, right? So rate meaning that how many customers are entering every, let's say, minute from the door, right? But the time is what is the average time between 2 customers? Average time. You understand that? Everybody understand that? So one is time, the other is the rate. And I told you last time, the whole game is about understanding whether you have in front of you the rate or the time. So lambda, is it the time or is it the rate? Well, the answer is rate. Rate always have a unit where you have per second, per minute, per hour. Whenever you see time in per minute, per unit hour, something like that, you're looking at the rate, which means that it is lambda that is given to you. Same goes with the mu. Customer served per second, per minute, per, so it's per something. But when you see time, let's say time between inter-arrival time between customers is 5 minutes. Now it's not per minute, it is minutes. No, I mean it's not per minute, it is minute or second. Any time unit, whichever time unit you're using.
So what is the difference between these two?
One is, look, arrival rate is, as I told you, so each minute on average how many customers enter. Let's say 3 customers per minute. So if you like you try to record for, let's say, 10 minutes, so 1 minute you'll get 2, 3, 2, 3, 1, but on average you'll get 3 customers per minute. You understand that? But what is inter-arrival time? If 3 customers on average are coming in 1 minute, so what's the average time between their arrivals?
33 seconds.
33 seconds. So they are completely related. You understand that? You need to understand this relationship. So how do you get time? You only do 1 over lambda. So 33 customers per minute, 1 over 3 is 0.333, right?
Yes.
Right, so 33. So you understand this basic difference. See, same goes with mu. So if service rate is customers per second, so service time, which is the time on average, a server serves on a customer, right? For example, if you're a cashier, so how much time on average you spend on a customer, that's service time. Okay, so you can get that by doing 1 over mu. So they are completely related. So if you know mu, you can find time by doing 1 over mu. Everybody understand that? If you know service time, you can find service rate by doing 1 over. So it just flip and you get the other one. You understand that? Now another thing that we studied last time was the system load. System load is lambda over mu, arrival over service. and this is called row. This sign is called row, and this is also called system utilization. It will tell you in percentage how much time the system is busy. And the stability criterion is it for a system to remain stable, it must be strictly less than 1. Even if it becomes 1 or more than that, your queue does not remain stable. And what does not remain stable mean? Not remain stable mean that if you go to Hajj and go to Al-Baik, this is what unstable means. It means that the queue keeps growing and growing and growing and growing and growing, and you get problem out of hand. So if you go on King Fahad, Causeway over the weekend, so the arrival rate becomes faster than their service rate. So you have cars getting more and more and more and more and more until the peak hour goes away and then starts to become less again. Okay, so instability simply meaning that your queue will keep on growing, right? Everybody understand that? Then we just looked at few formulas, and I'm not going to go too much into the formula, but there was like average number of customers in the system, average number of customers in queue, waiting time spent, and I showed you that there is like some formulas you must know. Okay, so this is like average number of customers in system is, how to find rho. What is rho? We just saw it on the previous screen. It is lambda over mu. So in any calculation, you need to first find lambda over mu. After that, you just put rho, and and you can find the answer. So if you know these things, let's look at possible questions that can come. That can come in the exam. Okay. I'm going to start with a simpler one, and then I'm going to show you one additional thing that normally comes in the exam. This is where students mess things up. Okay, so I'm going to show you where students mess things up, and then I want you to make note, write it down somewhere, because exams are far away. Even if you feel that I understand, but I can assure you, by the time 1 month passes and then you have an exam, and then I don't want you to forget about it. Okay, so let's read the question in MM1Q. So all these formulation that we have studied, there were two formulation sets that we studied. One is for MM1Q. You remember MM1 meaning? M1 means Markovian arrival, Markovian service. Again, if you forget, random arrival, random independent service. And the other thing we studied was MD1, random arrival but deterministic service. Deterministic meaning like fixed service times. So there are two formulations given. So just two kinds of problem we studied. So MM1Q. Now this is where I want you to listen closely. Now read the question carefully and tell me whether I'm giving you lambda or 1 over lambda or mu or 1 over mu. That's the only real problem that students face. After that, khalas, it's just putting the numbers into the formula and then it's fine. The rate of customer arrival is distributed as Poisson with mean 2 customers per minute. So what is given to you?
2 customers per minute.
What is that?
Lambda.
Lambda. Because first of all, you only have two things, arrival and service. Secondly, you have to see whether it's a rate or a time. Now read again the rate. We have given it to you. Of customers arrival. So it's about arrival. So we are talking about lambda. Okay. The rate of customer arrival is distributed as Poisson with the mean of 2 customers per minute. Again given it to you. Then look at the time unit, minute, customers per minute, right? Arrival. So what is given to you? It's 2 lambda is given to you, so lambda equals to 2 customers per minute. Okay. The service rate is exponentially distributed as 0.05 customers per second. So here service rate, again giving it out to you, is exponentially distributed 0.05 customers per second. Now one of the tricks we played, we gave you the rate directly, is that one was given in customers per minute, the other is given in customers per second. Make sure the times are aligned, right? So they have to be in the same. When you do rho equals to lambda over mu. So one is in per minute, the other in per second. No, you need to bring them down. Okay. So okay. So what is the average inter-arrival time for customers? Now they're asking what time between arrival of two customers. Very easy. You have the lambda. So if lambda is given to you, they're asking for time, 1 over lambda, which is 1 over 2, which is 0.5 minutes. Very easy, right? Straightforward. What is the average service time in minutes? We are making your life easy by explicitly asking you to give that in minutes, okay? So customers per minute. How do you convert seconds? 1 second
Multiply.
equals to 1 over 60, right? So 60 goes up. So 0.05 into 60 is actually 3. 0.05 into 3.
So 0.0 times
0.05 into 60 equals to how much?
No, 0.0 times 60.
0.05. It's 0.05
0.05 times 60.
is how much? 3. Right, so that's why we have 3 customers per minute. And for service time, it's 1 over mu, 1 over, right? Straightforward. What is the system load? What is the formula for system load? I just told you it is,
Arrival rate over service rate.
which is 2 over
3.
3, right? Which is 66.
Lambda over mu, right?
Lambda over mu. So is it stable? That's the next following question.
Yes.
Why is it stable? Because
Less than 1.
less than 1, right? And then what is the average number of customers in the system? Now, to answer that question, you just need to know the formula for average number of customers in the system. What is the formula? Rho over 1 minus rho,
Yes.
right? So you just have to put like 0.66, you know, whatever, or 66 over 100 minus 66 if you're dealing with it in percentage, okay? And then, so you substitute that and it turns out to be 1.94. What is the average waiting time for customers? Again, average waiting time for customers formula is waiting time. You see here, rho over u1 minus rho. So again, you just have to substitute and get the values, okay?
So the
Now-
average time Roma over mu times 1 minus p.
Yeah, so it is basically this is it basically says that waiting time okay, right? So what is rho? Sorry, what is rho? 0.66 1 minus 0.66, and what is mu? 3, right? So can you use your calculator? So it is 0.66 into 0. What is this? 34.
Calculator is necessary.
Yes. Right? Now I'm going to show you another problem which does all the same things. Okay. And by the way, okay, let me just first talk about MD1. MD1 works exactly in the same way. There is only one difference. Instead of lambda, you use the term D for arrival. Okay. Sorry, not lambda, sorry, mu, because it's a service. So lambda remains lambda, okay, but mu becomes D in the formulas in MD1, okay. So if in an MD1 queue the rate of customer arrival in minutes is distributed Poisson with a mean 1.5. So what is given, lambda or 1 over lambda? Read again. Rate of customer arrival in minutes, mean is 1.5. Rate, it's giving you out rate. which means that 1.5 customers per minute rate is given to you. Rate, we use the word rate here, so we have given it out to you.
Yes.
1.5 because it is MD.
No. We did not write the units here, but it's given here. Rate arrival in per minute. You
Already
know.
give you the.
Yeah, so it's 1.5 customers per minute. We should have written customers per minute.
No, 1.5 customer.
No, it's average arrival. Average arrival. Average arrival does not mean, it means that imagine 3 minutes. During those 3 minutes, or 2 minutes, let's imagine 2 minutes. So in those 2 minutes, 3 people came. You understand that? So what is like the average number of customers arriving per minute?
1.5.
1.5. That's the idea behind it, right? So in 10 minutes, you have around 15 people coming. So it's like every 1 minute there's like 1.5 customers. So that's the concept behind lambda rate. That's the concept behind it. Okay. So again, the service time. This time, what do you see? This time it's not. I don't know how sensitive this cable is. So this time service time is given to you in minutes, not the rate. So 1 over D is given, not the D. You understand that? 1 over D is given to you, not the D. So to find D, you actually have to do
What do you mean?
minutes. See, service time, minutes.
Okay.
It's not rate. Like mu it's not mu, it's 1 over mu given because it's the time, not the rate.
The above is the rate.
Yeah?
The above is the rate.
The first one is the rate, but the second one is time. So whenever you have time given, you do 1 over to convert it into the rate. Or the rate you convert it into time by doing 1 over. Everybody understand that? So 1 over, you just have to do 1 over. And the rest are just the formula set. You just need to know, and this formula set.
1 over 0.5 to convert it to the rate.
So 1 over 0.5 is how much?
Like 5, I think.
1 over 0.5 is how much? Yeah? 2? So it's like 2 customers per minute is like their service, right? Now, I want you to now look at another problem, which most likely will come in the exam. So it can be the problems before, but this one is also very important for you for your projects as well, this sheet to see. And in fact, this problem is inspired from your projects to think that, if you have done your projects, you know how to get things done. So the problem is given to you because you are supposed to have done your projects well. Okay? So instead of giving you lambda or mu, what we will give you is the data. And you have to find the lambda and the mu from the data. So what do you see here? What do you see here? The first table is, consider a single server situation. Data is collected for the customer arrivals 20 minutes. So you spend 20 minutes to collect the data, okay? As well as service times 30 customers. So 30 customers, you recorded how much time each one is spending on a cash counter, okay? 30 customers in 20 minutes. The queue is follows first in, first out. Customer population is infinite. The MM1. It's basically saying that it's MM1 queue. So now it's asking you to calculate system load and all those things, but let's see what you have here. So if you take the average, first minute 3 customers came. Second minute how many came? 2. Third minute 0. Fourth minute 2. Fifth minute 0. Then 0, 1, 2, 3, 0, 1, 2, 3, whatever. Now you have to find the average rate, customers per minute, because it's giving you in minutes, each minute how many came. So how would you find lambda? Lambda you will only find by taking the average of all these values. Class, it's not very difficult. So you sum them up and divide with those 20 minutes, right? So that's how you get the lambda. Everybody understand that, lambda? But the other thing that you have that have been given to you in the data is not like how many customers coming in each minute. It has given you for each customer, how much is the service time?
So the average.
First you take the average, but what you got after the average is not mu, what you got is 1 over mu, because it's the time, not the rate.
So times.
So what you do actually is, I hate this cable. Okay, so when you take the average, what you get is not actually mu, it's 1 over mu. Right?
So
Because it's the time.
We do.
So to get the mu, what you do, once you have the answer, you do 1 over that. So you get the mu. Everybody understand? Yes.
So the service time and customer time, it will be given to us, the data.
Yeah, data like this can be given to you. Right?
We need to get the mu and
Yeah, so you have to be careful. Is it the lambda or is it the mu or is it like the 1 over mu? So here's the tip for you to remember. What do you see here in this column?
Number of customers.
Here what do you see?
Service time.
So when number is given, it's in rate, number of customers. You understand that? So when you take the average, you are looking at the rate. But when it is given to you like time, the actual data that you are taking average is actually a time, not a number. When the data is in numbers, you're looking at the rate. When you're looking at the data in minutes or seconds, that's the time. Then you're looking at the time. So you have to do 1 over after taking that. Is that clear? The rest of the problem is exactly as I showed you before. That once you have the lambda and the mu, so what is the customer arrival rate? Right, you already calculated by taking the average. Answered, right? So what is the service rate? Service rate is, in fact, this question was given 3, 4, 5 years ago in the exam. So you are looking at an actual problem. Okay. So even the marks are we are just to give you a perspective of how much marks we can have. Okay. So and then it's asking in standard candle notation, what problem do you see? Now, when we were looking at the queuing lecture, there was a discussion on how do you identify how do you identify a queue? So you always have arrival. Then I told you second one is service. Third one is number of servers. Fourth one is capacity, finite queuing capacity or something. And then service discipline. So now let's just read the problem again. So it says your options are M, D, G, and there can be more. M stands for Markovian or Poisson. Okay. Now let's read the question again to see whether we are able to say whether it's MM1 or not. Read the question again. Consider a single server situation. Data is collected for the customer level which presents. So the queue follows first in first out discipline, while the customer population is considered infinite. So we have a single server, right?
Yes.
And then we have infinite, queue capacity, right? Service discipline is first in, first out, right? And then it must have said somewhere that the arrival, the customers independently, customer arrival and service are independent of each other. When I told you, when you hear the word independent, random, it's Markovian, right? So it's not given to you directly, but indirectly for you to know that because the arrivals and service are independent, you're looking at Markovian, okay? So MM1, or you can say that MM1/infinite/FIFO, but you don't write, because infinite and FIFO is like the default value. So even if you don't write it, it's perfectly fine, okay? Let's look at the next. Sorry. Okay. So MM1. So what is the customer inter-arrival time at the service counter? Now customer time Inter-arrival time means time between arrivals. So you have the lambda. You have the lambda, right? So 1 over lambda will give you time. It's as simple as that. Okay. What percentage of time you expect your server to be busy? Now it's just a game of words. What percentage of time your server is busy? What am I asking?
Average.
The load. The load.
Load. System load. System utilization. It's just an explanation of row. I told you row is the percentage of time the system is busy. So instead of asking you for row or utilization, I'm just asking you what percentage of the time the system is busy. Okay? So it has to be one of the same thing. You just have to have your common sense up. So, and the formula for that is lambda over mu. Okay. Is the Q stable in the long run?
Percentage lambda over mu.
Yes. In percentage, it could be turned into percentage.
Time,
Could
you
be
mean time,
fraction.
you mean
Multiply
times
by
100?
Yeah, that's it. Right? You just multiply with 100. will
So
give you-
1.65 divided by 1.5 times 100.
Yeah, I think maybe there's an error here. Calculation, it should be more than 100. More than 100. Can you find 1 over 65 over 1.5? Maybe it's just a calculation mistake because here lambda is faster than mu.
It's 1.1.
1.1.
1.
So because it's 1.1, so it's actually not 96. Maybe it's actually 101. So what is the answer to the next question? Is this Q stable in the long run? Yes and no, and why?
No.
No.
The answer is no, and why? Because the arrivals have become faster than the service. That's the answer. Okay. So and then you just substitute the values here. Average number of customers, average number of waiting time. Just put the formula. So you understand few different kinds of things. Now what I will do is I will share with you these two problems, and then I'm going to share with you some sample problems with you, which is like which is more or less talking about the same things. Okay, so you have sufficient problems to practice. My problem is that I've seen people they may look at the problem but they miss on those small things. 1 over lambda is the most common one. When you miss converting a rate into time or time into rate, right? Or misinterpreting that I'm asking about row, system utilization, slightly different words, and it can become problematic, right? That's the only thing. But otherwise the problem is straightforward, right? Do you see any complexity in these problems? The only thing is that make sure you be careful about rate versus time, right? And whether you understand from the words whether it's the lambda, mu, and rho, the only three things. If you know the two, there has to be the third one. There is nothing else, right? Even sometimes you can use your common sense of that I know the other two, so it means that I'm asking about the third one, right? Isn't it? So and the third one cannot be asked unless you answer the first two. So it has to be some very, very straightforward relationships. Okay. Now there's one more thing I wanted to mention. Now since I've asked you to here. Since you are asking about the projects, can we find the data set? No. So actually you are supposed to be collecting data like this. You understand that? So for example, you have to develop your conceptual model, okay? And then we will have to sit and decide where is the arrival, where is arrival happening. Usually arrivals are happening in one place, usually. It can be more than one place. Okay?
Arrival.
Entry, but what if there are two entries, right? But it's a tricky question when you say entry. Entry to where? To the shop or to the queue? Yeah, that's why I say you have to develop your conceptual model, and I will tell you where what is the place where you're going to record the data. So if you're going to Panda, and then you stop at the door, khalas, you're completely gone wrong. So you have to stand where customers are joining the queue, right? So because it's the same number of, there are 5 counters, so it doesn't matter. So wherever they are coming from, it's basically the same entry to the same set of counters. Okay. So what I will tell you is that you have to print a paper with time here, and for your particular problem, we have to decide whether time unit, good time unit is in minutes or is in hours, or is it good in what? Okay. Imagine that in typical situations like restaurants and like grocery stores and like King Fahd, Causeways and these kinds of things, usually per minute is always a good time. So then at the arrival you have to count each minute, count and add, count customers. And normally people, what they do, they just do stand somewhere or even somewhere far, or sometimes some managers are more problematic, so they say, what are you doing? So you explain. So sometimes they say, bring a letter, and khalas, even that is done. But I've never seen any big problem in collecting this data. What about the service? Service is time. So for example, if you're standing on a cash counter, you want to record times. So the real problem is when you say service has started and when you say service has ended. Okay. So for example, in grocery store, you just have to set the rule and then follow the same rule. So if I'm standing on a cash counter and paid, fatura given, khalas, go, and then I turn, service start. You have to make a decision of when the service starts. Okay. And then come and then you scan, you pay cash. As soon as you give the receipt, the fatura, khalas, service ends. So you need to know the time.
What about the restaurant? The service time should stop when you receive the receipt?
No. That's a very, very good question, and that is why I say we have to go problem by problem. So in that case, you are actually not looking at you are having queue in series. So you're not receiving one service, but you're receiving 2 services. First service is the cash, and second service is the food.
What's his question? I did not understand.
You say for restaurants, how do you measure service times? Because you pay and then you get the food. So I'm saying that sometimes even that you have to understand how they are working. Sometimes I pay, I give my paper to the person who's making the food. This is where my service starts, right? Or if it is going automatic, khalas, as soon as you go there, as soon as this service ends, your next service starts, because somebody is preparing the food. Okay. So but we have to discuss, what do you mean by service in that scenario? That is why I said, in the project you first develop your conceptual model, and then we decide what service means and where and how you're going to record. But there are small tips I'm going to give you here, because you will face even practical problems. For example, in service times, one of the tricks that has worked very well is your lap thing in the cash counter.
Yes.
So for example, when a person comes in on the cash counter,
Press.
so and then somebody has said scan, and as soon as you fatura and you stop, and then the next already started off, I'm late. So
Press
lap. So you have recorded the first one, and the second one has started, because that's how the cash counter works. Okay, and then you lap, and then you have all those times that you can record. So there will be some practical even issues that we have to discuss. How you're going to collect that, then and so on. So you understand that. So this basically we have talked a little bit about the data collection as well. Okay, so we have so far talked about. So I'm going to please remind me, or I'm going to send it to you, the sample problems, and then you can forward it to everyone. Okay, and the practice problems with unsolved practice problems. Okay, that people can look at. Okay, so So last time we started talking about the simulation. Simulation, you use simulation when queuing problem becomes queuing networks, and they become like you don't have the math to deal with it, right? You don't have that row formula for it, or you don't have like rho over 1 minus mu 1 minus rho. It's driven for MM1, not MM2, or not networks in series, right? You understand that? So in that case, when you don't have the formula, which you don't have in majority of the cases, except for simple MM1 or MD1, you actually will use what is called the simulation. So last time we started talking about that. I'm going to go full screen so that you can see it better. So, and by the way, quiz will be from this lecture. And again, please remind me, I have even recorded lectures for the rest. I should not tell you, because then you will even stop coming. Yeah, but at least for this lecture, I can share, the recording. Okay. So I should not have mentioned this to you.
Do you have recording for the Lambda and?
For the queuing chapter, and actually for the whole course, even for clustering. Yeah, during COVID we recorded it, so those older recordings are there. Okay, not recorded separately, but during COVID, because we used to have online classes, so during that time we recorded many of those courses. So if you need, I'll be inshallah be able to share that. So discrete, and this type of simulation that we use is called discrete event simulation, okay, which is applicable in solving so many problems that appear in where queues appear in all those things. There are different ways to deal with problems. So what are the two objectives that typically you deal with when it comes to queuing? And this is, I told you that even in projects you have two objectives. Number one, performance measure. Number two, improving the system performance, right? So that's what you see. One of the things simulation can do is measure, estimate performance, and the second one is improve operations, and the third one is basically the second one, which is, if your queue is getting unstable and out of control and failures occurring, and many things are occurring, so it's about improving the operations. Okay, so it's only the main two things. So how do you achieve these two objectives? Last time I told you that we can do that by actually measuring all the data in real system and calculate, right? And then to improve system, again we make change in the actual system and hope that it has improved, and then you measure again, and if it is not good enough, you change again. This is called experimenting with actual system, but it is, as you can see, it's problematic. Why? Because it takes time. When you change, it costs you money, and after spending money you find out that it's not working. Plus it will take 1 year before you make a conclusion. Second thing is that in engineering, which works more, is the test, experiment with the physical model, scale model. But this is not for us. This is mainly for engineering, where they have built small cars or something, and then they test small planes, test their aerodynamics and so on in labs. The third one is for us again, which is use mathematics. You just use mathematics, queuing mathematics, right? But if the math fails, what other options you have? Which is the simulation. That's why we are learning simulation. And by the way, the simulation is used by engineering, business, everyone else. Okay. So this is basically a typical simulation scenario or queuing scenario that you face. You have, in your model, you have certain inputs and you have certain outputs, and then you have the queuing model, which captures the whole thing that is going on. And this is what you are supposed to be doing when you pick a project. You'll have to develop a conceptual model, and this you have to create a model for it. Okay. And so what are the outputs? The outputs are nothing but your performance measures. Performance measures could be, now this is where it may differ. For your case, utilization may be more important than queuing size, because the resource that you're looking at is very expensive, very, very rare. So in such cases, resource become more important, right? For example, a very specialized doctor, that's the only one in the city. Even if the queue you have to wait for 1 year, people say, sometimes some specialized doctor, they have very long queues, right? But you wait because that's a very specialized resource. But then you can have waiting times in where you have resources are common, but serving to the customer becomes more important, right? We should not make you wait, like in grocery stores, like in restaurants and so on, okay? On the other hand, you have input parameters are things like how many servers you have, single queue, parallel queue, queue discipline, all the other things that we have discussed. Okay, so just give me a second. I think my laptop is about to be closed.
Doctor, how much we have left?
We'll see. Okay. I will inshallah try to finish within 15 minutes. I focus on this one and inshallah we'll finish it then. Okay. So where are we? Okay, so this could now queuing model will capture everything. It could be a single arrival, multiple queues and whatever configuration, right? So even for your projects, we may have to develop a conceptual model like this. Now, I'm going to jump a little bit. The rest are something you can even listen to in the video as well. These are just some trivial information, but this is where I told you that this is your project landscape. Plus, this is also important for your exam. This is also important for your quiz as well, right? The whole way of doing the simulation study. Problem formulation, model conceptualization, problem objectives, data collection, and all those things. Now, in all these things in model conceptualization, I'm going to spend time on problem formulation and model conceptualization. Okay, so problem, it's a statement of the problem that is needed to be said. Meaning that what? So if you go to a hospital and there are long queues, so that's your problem. It does not have to be too complicated. You understand that? So if I go to a hospital and I have to wait for 2 hours every day on average, so you define that as a problem, right? That's your problem. The formulation is the conceptual model that you develop, right? But the problem is basically that in defining your objectives, you must determine the questions to be answered, identify the scenario to be investigated. Questions to be answered include, things like what is your decision criteria? So when you're going to redesign the process, what is your decision criteria? What do you think is your decision criteria? I want you to go back to think about both your objectives. When you say now this system is better than before, how do you do that? What is the thing that you look at?
Service time.
And what do you call those things together?
Performance.
Performance measures. So you understand what decision criteria is? Decision criteria are your performance measures that you use to make decision about your system. Whether it's good, it's bad, you have to do something about it, whether now after the change it is good or not. Okay? Do you see down there? I wrote there explicitly so that you don't forget. Okay?
Mm-hmm.
Do you see this here on the right side? Let me just turn on my laser pointer. Yeah, do you see this one?
Mm-hmm.
These are all performance measures are your decision criteria. Scenario is basically your queue configuration, queue network that defines your queue network. Is it first in, first out? Is it single queue? Is it parallel queues? It is queues in series. Is it first in, first out that you follow? So this is called scenario. And then data requirements are, the data that you have collected and the fitted distributions. Okay, so far so good. So three things: decision criteria, the data requirements, the scenario, and of course you need to determine the end user, meaning that the customer, who the customer is. Okay. And of course, you know, there are this is basically when you do it in real world. What is the budget you have? How many time, within what time your company wants to finish your project, and so on. You know, it's basically project management side of things, which you are studying now, right, in project management course. Okay, so there are two different models. One is called conceptual model, and one is called the logical model or the simulation model. You need to make a distinction between the two. So one is the real world system. Real world system means I go to Panda and there are queues. That's the real system. So when I develop my concept about it, you know how that system is working, that's a conceptual model. But when I convert that concept into Arena, I code it, I program it, I write a code for it, then that's called a logical or a simulation model. Why it is important to distinguish between them? Because later when we talk about, so this is basically a conceptual model. Later when we are going to talk about it, you will see that sometimes the problem is not in your concept, the problem is in Arena. You have not coded it well. So the problem is in the logical model, not the conceptual model. But sometimes you have done your Arena very well, but still something is wrong. You go back, look at your concept, and it's not capturing exactly how the real world is working. So that's like the issue of conceptual model. Okay. We will later talk more about that, the difference between conceptual and logical model. Okay. And there's something called validation, verification, and you know, one is look at the conceptual model, the other is look at the logical model. Okay, so we'll talk more about that. But at least you can appreciate that conceptual model is very important, because whatever you design in conceptual model will be used by your friend or your colleague to write the Arena simulation model, right? So you have to define the conceptual model very well. So conceptual model captures many things. It captures something called events, activities, entities, attributes, resources, variables. This is where we have to become formal. Formal meaning that in system analysis design you have 1, 2, 3, 4, 5 things you have to address, right? So in simulation you have to address these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. Okay, which means that when you're going to work in your project, I need to see where are your events. Where is your entities? Where is your activities? Where is your attributes, right? I need to see that reported, and I gave you in the sample report where, you know, your fellow senior students have done exactly the same.
We can't draw diagrams.
You can draw diagrams. Any kind of diagram is fine. Flowchart is fine, but after flowchart, you need to define each one of them. Okay, so let's just talk quickly about it. First of all, entity. What is an entity? Entity is a dynamic object that gets created, move around, and it is usually the one that gets service. So for example, healthcare example, it's basically the patients who are the entities. So in grocery store, who are your entities?
Customers.
Customers. On King Fahd Causeway, what is your entities?
Travelers.
The cars, right?
Cars.
The cars or the travelers, okay? So, and then you have something called attributes. Attributes are those sifa of entities which is important during simulation, not everyone. So if your customers, I'm not concerned about your weight or height or age or something, right? So, but they can be I may be concerned about your gender, because in university, you know, you have different areas for male and female. If gender, like in hospitals, in Panda, it doesn't matter, gender doesn't matter, but in hospital, gender matters, right? You have to, female go there and male go there. So in those, we are talking about those attributes that are important during simulation. Okay, resources. Resources are the things that give you service. So you have to identify service. So for example, in hospital, what are your resources? Start from the beginning. You enter, you go to receptionist, number one service. Your resource, or receptionist with the computer. Well, what comes next? Nurse? Nurse is your resource. Doctor is your resource. X-ray machine can be your resource, right? Anything that is needed to provide service. In grocery store, the cashier and the cash counter is your resource, right? So these are called resources. So again, in your project you have to, once you develop your conceptual model, you tell what is your entity, what is, if there is any important attribute to remember, or what are the resources. Variables. Variables is normally you do not have to worry too much about it in simulation, but you need to understand the concept behind it. So because Arena is doing a lot of variables for you, that's why I say you don't have to worry. But and variables are not about a particular entity or a particular resource, but something that represents about the whole system. So when we say total number of patients in the system, it's a number, right? It's not about you or you or you or you. It's about in the whole system how many patients are there, or how many doctors are free at this time, or how many doctors are busy at this time. So this is called a variable. And you can imagine we have multiple variables, right? Time is a variable, number of doctors, number of patients in the system. So all these variables together, we call them state. So state is what? 1, 2, 3, 4, 5, all important variables together, we call it a state. Why it is important to call it a state? Because we have something called an event. An event is, so when you're sitting with a doctor, is there an event happening at that stage? The answer is no. When you're paying the cashier and one item scanned, second item scanned. So when an item is scanned, is that an event? No, the answer is not. In queuing language, it's not. Event is something that changes the state of the system. When a new customer arrives, right? The number of customers changed in the system. When a customer left, when I moved from one service to another service, that's like a change in state. You understand that? So state, that's why we need state, because state will tell whether there's a change in system. Okay, not much left, so inshallah it will be fine. And activity is the actual thing. In simulation, when I'm scanning the items, I'm doing activity. When I'm reception, when I'm taking notes, getting pay money, I'm receiving money, right? Or the nurse checking me, or the doctor looking at me, that's basically the activity. For simulation, the actual nature of activity is not our business. So how the doctor is looking at me through stethoscope and all those, not my concern. So why activity is important? The only aspect that is important to me about activity is time. Remember I told you, when you're going to go to cashier, start noting the time, fatura paid, khalas, you note the time. Did I talk about how they are picking up the item and scanning, and some by that, right? Nothing I mentioned. So activity for us is only, basically pertains to time. Okay. Now I'm not going to talk about this one because this was the old thing. When you used to develop conceptual model, you used to write it in C, Fortran, or there wasn't any Python, but for you, imagine you have to write the conceptual model simulation in Python. So you needed to have, arrival and queue length increasing. If go there, then queue increase by 1 and decrease by 1, all those logic. The good part is that this is no more relevant, because everything is done in there. I'm going to quickly talk about a few more things, inshallah, then I will stop here. I don't think there's much left. Once you collect the data, you have to perform what is called input analysis. What is input analysis? Input analysis is, when I was solving the problem to you, I said Poisson with lambda distribution with lambda mean interarrival so and so value, isn't it? So how did you get that lambda value and call it Poisson distribution from those numbers? You understand that? So you, from this number to your distribution, is basically called input analysis. So Arena again can help you do input analysis. So the data you collected, you're going to just give it to something called input analyzer in Arena, and it will produce you those distributions for you. Not only Poisson, but if there's another distribution being followed by the data, so it will give it to you. Okay. Then we will talk more about both the topics. Will be discussed in detail more. but there's something called validation. Validation and verification are very, very important topics. So, I told you we have a real system, conceptual model, and the arena model. So, although it says validation, as you'll see, inshallah, in one of the next lecture, there are two terms actually used: validation and verification. And we will discuss more in detail, inshallah, in just verification, validation chapter. Validation is my conceptual model really representing the actual things going on there? You understand what validation is? So you will bring it to me, and how do we do validation? I will ask questions. Do you think this is going on? Do you think that thing is going on? So we discuss, we argue, and then we'll say whether this diagram that you have drawn is actually happening there or not. You understand what validation is? So we have to discuss, we have to argue, we have to say whether this represents the actual system or not. If it doesn't, it's a problem. If we all agree that it represents, that's absolutely fine. And then verification is you write the arena code and you check, like in Python, you used to check, do you used to debug? You used to check maybe x plus, did I write x plus 1 or x minus 1, maybe plus or minus something. You check the code itself. That's verification. Okay? Verification is to make sure your conceptual model is translated into arena correctly, and validation is, you converted your actual thing that is going on into the conceptual model correctly. Okay? So, so how do you do simulation these days? Well, we used to use 15 years, 20 years back, we used to use Java, C++, Visual Basic. Then came just as a matter of name, you need to remember this language called Simon. Simon is a programming language that is entirely designed for simulation, not like Python. This is a very specialized language. It has a construct called not for loop, etc. It has a construct called arrival, process, simulation, things like that. Whatever we'll talk about in simulation. Okay, so you can use Simon to write solution to your project, but is that good enough? So people have developed new software which even allows you not to look at even this programming language, but they have something on top. And Arena is actually part of that. Arena uses simulation Simon, but you never have to write Simon. So it's like drag and drop, like in Orange. Remember we used Orange? So Orange is built on Python. You can do the same thing in Python, but Orange helps you just drag and drop and use it. So Arena is like that. I think some of you got interested and they know more software that are doing simulation like that, right? You collected some more software in it. Okay, so Arena model looks something like this. You have arrivals, you have decisions. This is a decision, go this way or that way. Assigning certain attributes, going to different services, and then eventually at the end going out. Very simple. The actual Arena model, when you're going to build for yourself, will not take very long. Maybe if it is a complicated one, maybe 1 hour, 2 hours. It's a simpler one, maybe 15 minutes. So the Arena is very simple. In one of the classes, inshallah, we'll also learn Arena as well, because you need to know how to use Arena as well. But it will take like 1 hour session to understand all the basic ideas about Arena. Okay. So we have reached the end of okay. I think I need to quickly. I already mentioned that, but let me not miss those last few bits. I thought we have reached the end, but let me just quickly talk about that. I already have discussed that. Okay. I already mentioned about the difference between verification and validation, right? So it's just talking about that. Verification is the process of determining if the operational logic is correct, debugging. And validation is the process of determining if the model actually or accurately represents the system. I already explained this to you. So these are very two different things, although the name looks the same. Okay. So I showed you this diagram. So validation, verification is between the logical and the simulation model. And validation is you try to match whether it actually represents the real system or not. Okay. So validation and verification. Okay. I don't think we have to look into that. When you run the simulation, you'll face a problem, a philosophical problem, a conceptual problem. So if I go there, and I think you can appreciate it very easily. If you go to, let's say, Mall of Dhahran this weekend, you see a lot of rush. Fine, it tells you that you have a queuing problem. But would the same thing exactly would be repeated the next time? Exactly the same scenario, same number of people.
The numbers no, but the same scenario.
Maybe. So what you have tried to mention is that overall behavior is there, but not exactly the same. Okay. So when you're going to run your simulation, that's going to just produce that one time what happened. So in design of experiments, we will talk about that. And by the way, there's full course on design of experiments, so we are not going there. By the way, in Al Yamama right now I'm teaching design of experiment course. Is that how to deal with those situations? For us, we will do only one thing. Instead of running our simulation once and saying that this is my performance, okay, this is my average waiting time, this is my average number of people in the queue, because it just happened only once, I cannot generalize it. So what I will do is I will do a concept called replication that comes from statistics and design of experiment. What is replication? Replication means I'm going to run this experiment not one time but many times. So I'm going to run it not once, twice, thrice. Every time I get slightly different, waiting times and number of people in the queue. But if I'm going to run it for, let's say, 10 times, 10 weekends, what will happen? How much it will affect your confidence about talking about the rush in a particular store. The more you go there to a store and the more you see, the more confident you become in what you can expect, right? So replication is about that. So you will. The good part in computer is that when you're using Arena, you just say replicate 10 times, run 5 instead of 5 minutes, 8 minutes, 10 minutes, and it will give you the average of those 10 replications. And those average of 10 replication meaning that you are more confident. That's how we do design of experiments, right?
We don't have to collect the data multiple times.
That's again a very good question. If you're solving a real world problem, you have to collect it at different times. You have to collect for the longer you collect, the more different times you collect, the more realistically you are capturing the scenario. But I'm talking about even when you're running the simulation, still a random process. So you have to run it several times before you say, and you take the average of all of them, and this becomes like a better representation of what is happening. Because imagine what. One replication by chance, because of random process, you suddenly get too many customers, and you conclude that I have big queues. You understand what I'm saying? Or another day you run a replication only once, and because it's a random generator, so there's no customer, which can happen, right? So it says, khalas, my system is fine. But when you run it like 20 times, the chances of getting low customers sometimes, high customers sometimes, medium number of customers, you capture all of them. And then the more you run, the more common scenarios it will keep on producing. And then you take the average, and the average will become a better representative. Okay? So I'm going to now stop, and inshallah